good?
Okay.
All right.
Now we got
So today, here's what we're going to do today. We're going to do a quick review of some of the properties we did the week before spring break. Just to kind of review, some people are gone, maybe you just don't remember. It's been more than 7 days now. So I'm going to review the Pythagorean Theorem and some of the properties about it. We'll do a few examples of how we're going to use it today. We're actually going to see maybe 2 or 3 different examples of different types of problems we can do. And then we're going to go back to something we saw in the very first section, because I haven't come back to these 2 things yet on the altitude and light formula to show you like the big tie-in. That now that we know the Pythagorean theorem, how it can make these problems easier, and we're gonna discuss that. So we're gonna do maybe 1 or 2 examples of that. So that'll be kind of our goal today. We are gonna get homework today. That'll be kind of the idea. It'll be due later this week. Again, possibly Wednesday or Thursday, something like that. It's not very many problems I think I could cover. Please, 18 problems, something like that. But it's based on Pythagorean theorem, so you should know what you're doing. In fact, some of the problems that we're actually going to see in the homework were some of the examples I provided you in class that we did those last couple days before break. But let's jump right in. Let's talk about the actual Pythagorean theorem. And again, if you don't have your book or notes or calculator, make sure that we get a chance today. Maybe you want to go grab those. All right. Let's do a quick review of the Pythagorean theorem here. Pythagorean theorem, if you don't remember, it only works for right triangles. If it doesn't work, then that means you don't have a right triangle. That's like the common sense way to think of it. Basically, what it's talking about the legs and the hypotenuse. The hypotenuse is always the biggest wall of the right triangle. How the Pythagorean theorem works? You take each of the legs. Doesn't matter which one's which. In the book, they call these A and B. Doesn't matter. And then the hypotenuse is always C. So the formula is A squared plus B squared equals C squared. So the 2 legs, the walls that touch the 90-degree mark, you square them, you add them together, that equals the biggest wall squared. If that works, you have a right triangle in the first place, so both sides should be equal to each other. And third, if you're missing one of the numbers, you can find it. So one of the problems we talked about in class, you know, I think it was the Thursday before spring break, was what happens when I give you 3 numbers. So here's an example of it. Something like this. Somebody had these numbers on that the day right before break. Hit enter here. Okay, so 9, 12, and 15. So when you look at these 3 numbers, I don't know what type of triangle we have here. That was the question that we did. Is it acute, right, or obtuse? Obviously, you can tell by the 3 numbers, it's definitely scalene, right? The 3 walls are different numbers. But which wall, in theory, should be the hypotenuse?
15.
Yeah, the 15, because the hypotenuse is the biggest number. So this 15 has to go here. So that's your C number. That's what you need to realize. The hypotenuse is always the biggest wall. So this, in theory, would be the 15. Then it doesn't matter where A and B is. This would be the 9 and the 12. And we want to check, does the numbers actually work? So this would be 9 squared plus 12 squared. And we're trying to see, does that equal the 15 squared? Well, 9 squared is 81. The 12 squared is 144. And 15 squared is 225. 15 times 15. And so now that we have that, we would add these together and see, does it make that? And sure enough, it actually does, because 144 plus 81, you actually do column up and add those together. That's a 5, that's a 12, that's a 2, so it is 225. So they're in fact equal to each other. So the question is it a right triangle, obtuse, or right? Well, since both sides are equal, it is a right triangle. The formula worked, so it has to be a right triangle. All right, any questions on the setup on that problem? Like how it works, why it works? You're going to have, I think you have a few of those today. I'm not sure on the numbers. I'll have to look back at what problems I picked. But they're going to give you 3 numbers. They're going to ask you, is it obtuse, acute, or right? Now, how do you know if it's obtuse or acute? Because obviously right, if they work, they both equal, it's a right triangle. How do we know if it's acute or obtuse? Obtuse is if the C, the hypotenuse wall, if this number turns out to be way bigger, then it's obtuse. If this number turns out to be really, really small, the hypotenuse turns out to be smaller when you square it than the other two added together, so this number is small, then it's a cube. That's how I can tell. The C number tells me everything. So for instance, maybe it wasn't 15, maybe it was 13. So it's 13 here. So now this is 13 squared, and that would be a 169. Well, since that number is too small, now you have an acute triangle. The wall by itself tells you everything. Okay, makes sense what you're going to have to do today. Now, there was one problem I did not hand. I believe maybe I handed it out by accident. I think I took it back right away. It was one of these, and this is one of the problems I saw in the book. I never, I will not assign this problem today, but it was one of those problems that I think you could learn something from it, like especially when you first see it. This is one that I saw in the book. I typed it up here, not the decimals. The decimals you just have to be calculator. It was that problem. Let me hit enter here. It was this problem. They had square roots. And I don't think we did any of these problems a couple days leading up to break. We had to figure out first, because the problem is I don't actually know which wall's the biggest. There's an easy way to figure it out by manipulating the numbers to go back in the square roots. But the trick is, what I would actually do is I would type these on a calculator to actually figure out what the numbers are, like what that actually is. So you take 2 times whatever the square root of 3 is. And whatever that decimal is, that's an approximation on a calculator. We can figure that out. Now, in theory, how you do this without a calculator, if you don't have one in front of you, the trick is you put the 2 back on the inside with the 3, and you have to use that little trick that when you put numbers back on the inside, you have to double them. So if I put the 2 back on the inside, there's actually 2 of them. Because if you think back about how square roots work, you circle pairs, you kick one out. So there are actually 2 of them in there. So this is actually the square root of 12. Square root of 12 is between 3 and 4. Because 3 is 9. 3 times 3 is 9. 4 times 4 is 16. So it's between 3 and 4 is a decimal. This number, if I put the 4 back on the inside, this is 4 times 4 times 2. Because you put the 4 back on the inside, so there's 2 of them. So that's 16 times 2, which is the square root of 32, which is almost the number 6. 6 times 6 is 36, so it's really close to 6. It's like 5 point something. So 5 point something, don't know. This is 3 point something, don't know. And this number over here is 3 times 3 times 5. So I put the 3 back on the inside, which is 9 times 5, which is square root of 45, which is really close to 7. It's 6 point something. So which number is obviously bigger? That, yeah, the 6 point something. So that's how you do it if you didn't have a calculator. I personally would just type in the calculator just to figure out which number is bigger. But now that we know which of the 3 numbers is actually the largest number, it's actually that one. Now you know like where to set these numbers on the actual triangle to see what type it is. So the 3 root 5 would technically be the biggest wall. The 4 root 2 would be here, and the 2 root 3 would be here, because it doesn't matter where those 2 go. Those are the 2 smaller walls. Then I'm going to try the Pythagorean theorem to see, does it actually work? Is it a right triangle? Does this number actually work out? So this is the question. So this is the problem that I think I may have accidentally handed it out last week, but I took it back right away. How you actually do this, when you square these actual numbers, so I take 4 root 2 and I square it, and you take 2 root 3 and you square that, and you take the 3 root 5 and you square that. So you can go to the Pythagorean theorem. A squared plus b squared equals c squared. And we're going to try to see, do they work out? How you actually square these, you square both numbers individually. So you square the power of 4, you square the 4, and you square the square root of 2. So 4 squared times root 2 squared. Well, here's the trick. The radical sign and the power of 2 are opposites of each other. They're inverse operations, because it's actually called a square root and a square. So when you actually square this, these actually cancel each other out. The symbol on the power 2. So that's actually just a 2 sitting there. Now the other way to think of that, if you don't like that they actually cancel each other out, so that's just a 2 sitting here. This is actually how you do it. When you take the square root of 2 and you square it, there's actually, what this means is that there's 2 of them. That's what it actually means. And when you multiply these together, you get square root of 4. Well, what's the square root of 4? 2. That's why it's 2. So I think the easiest way to think of it is the symbol cancels out. That's like a shortcut that they try to teach you in algebra 2. So this is just a 2 here, because this symbol cancels out. And over here, it's 4 times 4, which is 16. So this actually turns out to be 32. This is 4 times 4 is 16 times the 2. So that's 32. We're going to add that to the next number, which I'd square both of these. So that's 2 squared and the root 3 squared. So the symbol would cancel out there. This is 4, and 4 times 3 is 12. So that side, in all, adds up to be 44. That's that left side there. The right side, it's probably not going to be 44. But how you do this, we square both. Yeah, that's a 5, that's a 9, that's a 45, and you're absolutely right. That this side turned out to be too big. The wall that was by itself was 45 compared to the other wall. And so the idea is that when you compare, the one side's bigger, so you are absolutely correct. That triangle's obtuse. The one wall, the biggest wall is too big compared to the others. And again, how I justify the numbers, you can actually see my numbers here, where my numbers are coming from. My 12, my 32, and my 45. Because when you do that little trick by putting the numbers back on the inside, where you double them, put them back on the inside, and you square them, the symbols would cancel out. So that's actually what you're seeing there. I square them. Alright, questions on that one? I'm not going to sign something like that. It was just, I think it would be a disjustice if I didn't show you that, because that's something that you definitely would attempt in like an Algebra 2 class or a pre-calc class where they're going to show you square roots and how to square them. So I thought it was something that we probably should see. I know that, I think the ones that, the most difficult problems I saw in the textbook for us that I picked out, there's a couple that were decimals. So you just square them, just type in a calculator. There is a dedicated square button on the calculator, so you can find that. You just type in whatever decimals and square it. You have to add them up. Okay, any questions on the first type? Okay, perfect. That was, I think we did that the Thursday before break. Now, the second type of problem that you can do with a radical is the problems we did on Friday, right before spring break, where you had to find a missing side of a triangle. So I'm gonna put 2 examples up here on the board. So here's the first one. Get rid of this. Alright. So here's the first one. I don't know if anyone had this particular problem on Friday, but we had to find one of the walls. So the trick is you have to use the Pythagorean theorem. So this, if you think about this, like we're assuming that this triangle is a right triangle, and they're trying to figure out the missing wall. So this is my A, this is my B, and this is the C. Now how I know that, this is the biggest wall, because it's the one that doesn't touch the right angle. So these are my A and B numbers, my legs. So if you just do the Pythagorean theorem, a squared plus b squared equals c squared, we can find the missing wall. You just have to do a little bit of algebra. So this is the 23 over here squared. The b squared is the 8 squared. And I want to figure out my a. So a squared is equal, or a squared plus 64, e times a is 64. 23 squared, I have no idea what that is. What is that? 400 and... Way off. I said 529. So 529, and then you subtract the 64 across. And that ends in 5. What is it? Is that 465? And then we take the square root of that. And that is not a pretty number. Okay. Any questions with how to find the missing wall? Now, whatever this decimal is, whatever that number is, that would go here. Okay, that number is definitely less than 23, I can tell you that. It's going to actually go really close to that.
21.56.
There you go, 21.56. And I believe the textbook just says leave it as square root, so you can just leave it square root of 465. If you ever want to try to break it down, that's fine. You know, do that thing where you try to figure out what multiplies into 465, write them all down, and then you circle pairs and kick them out. But the book actually recommends that you just leave it as square root instead of type of decimal. But that makes sense. I mean, the big wall should be 23, so. All right, questions on what you're going to have to do in those types of problems. Now, it could be any wall. It didn't have to be the A wall. It could have been the B is missing or the C is missing. You just have to do a little bit of algebra. If the C is missing, then you don't have to really move anything around. I don't need to move the 64 across or anything like that, because if the C is missing here, then that problem's way easier, because the A and B numbers will be here and you just take the square root of it right away. So that's pretty easy. But again, A squared plus B squared equals C squared. You have to square. Okay, questions on Pythagorean theorem. I know I just blitzed through that as fast as I could get it. The goal today is actually look at these two things. How does the Pythagorean theorem work with problems we did previously? I think the homework assignment, which was that was the one that was due like the Wednesday before break. There was, if you knew the Pythagorean theorem, this is the thing we learned like Thursday and Friday that week, you could have actually used that for these problems to find, missing parts. So I want to talk about that. I want to show you an example out of the textbook and how that works. So let me put an example up here on the board. All right. Get rid of these pictures here. Okay. Alright, so let me give you an example of one of the problems we did, for that homework, that page 541. So you have a right triangle, and then the trick was they talked about altitude and legs. Well, this is an altitude. When you draw a line straight down to the opposite wall, and this wall is the hypotenuse of that triangle, this is the legs, right? This is the altitude. Well, what we did in class is we did problems where, let's say that they gave me these two numbers, like 3 and 12, and they wanted to know that number. Those were a problem we did in class. That was one of our theorems we had. It was they called it the geometric mean. That's what we talked about. I think it was like theorem 8.2. It's called the geometric mean. It was called the altitude geometric mean. And how that works, if you don't remember in class, we talked about that the geometric mean, or the altitude, you put the altitude here and here on a proportion, whatever the altitude is as the height, and then you put the parts of the bottom that it touches, the 3 and the 12, and that's the part of the hypotenuse. That was the formula that we did. In fact, let me put the parts down here, the actual words. Part of the hypotenuse and the other part of the hypotenuse. I think this is the formula that the book typed out for you. That was from the first section. Well, the numbers, where you'd actually plug the numbers in here, since the altitude is x, you put the x here and here, you put the 3 and 12 here and here, and then you cross multiply. So if I cross multiply x times x is x squared, cross multiply 3 times 12 is 36, and to solve you take the square root. What's the square root of 36? Yeah, that's the height. That's 6. Okay, that's fine. I mean, that's an easy formula. Most people can understand how that works. It's a simple concept. The part that was difficult about that homework was the second part. You had to find a leg. The leg, for some reason, always throws off people. That simple leg formula. So let's do this leg over here. Let's call this the letter Y. The leg formula, for some reason, is just the difficult one, because it's the leg that you're trying to find. So the leg goes here and here, whatever leg you're finding. The part of the hypotenuse that's closest to it goes either here or here, and then the full hypotenuse goes here. And that was the part that threw people off. They didn't use the full hypotenuse. So leg times leg is leg squared, so in my case that is the letter Y. The part of the hypotenuse that's closest to it is the number 3, and then what is the full hypotenuse down here? 15. And that is the part that some people forget. They're like, I don't have the number. You do. You add the 3 and the 12 together. So that's the full hypotenuse. And then to solve, you do your cross product. Cross multiply, and you set them equal to each other. So that's y squared equals 45, or 3 times 15. To solve, you just take the square root of it, and you can just leave that square root of 45. Or you can simplify that down. If you do that trick where you break it down into numbers, 9 times 5, or 3 times 3 times 5. And you circle the pair, kick it out, so it's actually 3 root 5. Right, that's the exact answer. I'll leave this for 45. But you didn't need to do that. You know, getting the square root of 45 here, breaking it down. The leg formula isn't necessary. That one is. You know, the altitude formula is. This one isn't. Now, here's the reason. There's another way to do this problem. I didn't tell you that. I was waiting for when we got through the Pythagorean Theorem to actually finish this problem, because when you draw an altitude straight down, what type of angle does it make right here?
Right.
Yeah, it makes a right angle. In fact, you have 2 right triangles. You could have just done the Pythagorean Theorem. So if you knew the Pythagorean Theorem, which you didn't at the time, you had to resort to doing this leg formula. You could have done Pythagorean Theorem on that problem to actually figure out what y is. Instead of doing this crazy formula here. Because I have a right triangle, so when you look at this right triangle here, so I'm going to look at this one, let me get rid of this part. I think this is a 6. I could have found y because I have my legs, and that's a hypotenuse of this right triangle. So the Pythagorean theorem is a squared plus b squared equals the c squared. So that's 9 plus 36 equals y squared. This is 45 equals y squared, and you just take the square root to the other side. That's how you could have done that problem. That was the number that we just talked about a little bit ago. So that was another way you could have done that problem, to figure out the legs. Or if I went to the other side of this triangle, I think the bottom here was a 12. That was a 12 here. Now you can find this number here, because you also have a right triangle again. I can do the Pythagorean theorem on that triangle. 12 squared plus 6 squared equals the z squared. You can solve that. So the reason I bring this up is that now that you see that and you see the Pythagorean theorem that's being used, it makes that original problem that we did, back in the first section so much more easier. It's way more manageable at this point to figure out the actual numbers. All right. Any questions with like the previous examples we've done or the new stuff? Okay, I'm going to give you homework today. I'm going to make it due Wednesday, Thursday. I don't really care which day you actually turn it in this week, because it's going to be in for the quarter 3. If you're going to turn it in Thursday, turn it in Thursday, like right at class, not at the end of the day. So I prefer it Wednesday, that way I can get it graded. But here's your homework. It is page 552. So page 552, it's 9 through 12, 14 through 18, 21 through 29. Okay, now most of those problems are just Pythagorean theorem. Just find a missing find a missing side of the triangle. You can leave them square roots if they don't work out to be perfect. Like if you want to leave it square root of 45, that's fine. Leave it that way. Some of those problems, I think it's the 21 through 29. Majority of those problems are, tell me what type of triangle it is. Is it right, obtuse, or cube? They have the numbers there for you. Alright, so there you go. Again, I'm going to make it do Wednesday or Thursday. If it's Thursday, if you're going to turn in Thursday, it's got to be Thursday morning in class. So I'll wait for the end of the day. There you go. If you have the rest of the time, you can move around, you can sit wherever you like. We'll probably have a new signature tomorrow. I forgot what did I make one this morning? So, have a new signature tomorrow.
How you finished it?
Just a reminder, I think today's the first day of girls soccer, so if you're interested in soccer, probably want to head down after school, talk to Mr. Bonzi, he'll be here.